Ever zipped through a toll booth and wondered, how'd they come up with that price?
Yeah.
Today's deep dive is all about the surprisingly clever world of toll calculations. And we're using 3.7.pdf as our roadmap. Buckle up.
You'd be amazed how much ingenuity goes into something we usually just take for granted. It's a fantastic example of programming principles in action.
Okay, so 3.7.pdf starts with weekday toll rates. And it's not just a flat fee, right?
Yeah.
You've got time slots affecting the price.
Before 6 a.m., it's only $1.50, but then bam, $4.60 between 6 a.m. and 9:59 a.m. That's peak commute time, of course, and those higher tolls help manage those traffic surges.
Makes sense. But this gets me thinking about how programmers actually write the code for this. How do you tell a computer to charge different amounts based on the time?
That's where things get interesting. See, our brains understand ranges intuitively,
Right.
but computers need it spelled out, like very specifically. The document even mentions this. It's a common pitfall for new programmers. They try to use mathematical notation like 0 less than x less than 10 to define a range,
Uh-huh.
which it throws the computer for a loop.
Because we're basically speaking two different languages.
Exactly. Programmers use logical operators to make those ranges crystal clear. Think of them like conjunctions and d or r.
Okay.
So 0 less than x and dx less than 10. That tells the computer to check if both things are true.
Okay, so it's like giving the computer step-by-step instructions, and this is where those flowcharts in the document come in handy, right? They're like visual guides to the code's logic.
Precisely.
Right.
Imagine a flowchart as a map. So you input the time, and the flowchart takes you through these questions like, is it before 6 a.m.?
Right.
If yes, then it's $1.50. If no, move on to the next step and make sure every input leads to that correct toll amount.
So let's put our flowchart navigation skills to the test. The document gives us an example. 9:30 a.m., if we follow the decision branches, what's the final toll?
Let's see, 9:30 a.m. So that puts us smack dab in the middle of that 6:30 a.m. to 9:59 a.m. window. So we're looking at
$4.60?
You got it. You're a natural at this. But it gets even more intriguing when you factor in carpool.
Oh, right. There are discounts for carpoolers, which means the code just got more complex.
Exactly. It highlights how programmers have to consider all these real-world nuances and translate those into, precise instructions for a computer. And in this case, it's encouraging people to share rides.
So how does the code determine the carpool discount? Is it just a flat rate, or are there different levels? It seems like there's more to it than just, a simple discount.
You're absolutely right. According to 3.7.pdf, a carpool is defined as 3 or more people. Now, between 6 a.m. and 9:59 a.m., they get 50% off the regular toll. But here's the kicker. Before 6 a.m., carpools ride for free.
Wow, free tolls. That's a pretty sweet deal for early birds. But it makes you think about the why behind it. Why offer that?
It's a clever bit of behavioral economics woven right into the code. You see, by offering this significant incentive, they're encouraging people to carpool during those peak hours, which in turn helps reduce congestion and, emissions.
So it's not just about calculating tolls. It's about using those calculations to kind of influence behavior and ultimately shape traffic flow for the better.
Precisely. And this is where programming goes, way beyond just crunching numbers. It's about designing systems that take into account human behavior and environmental impact and all of that.
Okay, yeah. I'm really starting to see the bigger picture here. So how would a programmer even begin to code something like this? Would they need a whole separate flowchart just for carpools?
You bet. 3.7.pdf actually includes one. This carpool flowchart, it considers both the time of day and the number of passengers. It's like adding another layer of decision-making to the process.
Let's imagine we're back at the toll plaza. This time, it's 7 a.m. and I'm driving solo. No carpool buddies for me this morning. What would that look like as we follow the flowchart?
All right, so we input 7 a.m. into our flowchart. First check is always the time, right? Is it before 6 a.m.?
Nope, not this time. It's 7 a.m., so we're past that early bird cutoff.
Exactly. So the flowchart directs us to the next byte. How many people are in the car? In this case, it's just you.
Just me and my thoughts. So, no carpool discount for me. What's the damage?
Let's see, 7 a.m., that still falls within that peak hour window of 6 a.m. to 9:59 a.m. And since we're not getting that carpool discount,
Hit me with it. What's the final toll amount?
you're going to have to pay the standard peak hour rate, $4.60.
Okay, $4.60 it is. But you know what? I think I'm starting to see these toll booths in a whole new light. They're like mini computers, quietly crunching data and making decisions based on all these different factors.
That's a great way to put it. And we've only just scratched the surface. Imagine the complexity of systems that, manage entire highways, coordinating traffic lights, toll plazas, and even things like electronic toll collection.
It's mind-boggling when you think about it. But here's a thought. What if a sensor malfunctions? Like, how does the system handle those kinds of, real-world glitches?
That's a fantastic question, and one that programmers have to consider, constantly. It's all about anticipating potential errors and building in safeguards.
So there's even more to it than just the basic logic of calculating tolls. We're talking about error handling, contingency plans. It's like this whole hidden world of complexity behind something we usually just take for granted.
Precisely. And this brings us to another fascinating aspect discussed in 3.7.pdf, handling different payment types. Cash, credit cards, electronic passes, each one requires its own set of instructions and, of course, its own potential for errors.
Wow. I've never even considered that. Okay, so we've gone from basic toll calculations to carpool discounts to error handling and payment processing. It seems like every time we peel back a layer, there's even more complexity underneath.
That's the beauty of programming. It's about breaking down complex problems into smaller, more manageable steps, and then building those steps into a system that can handle, a wide range of scenarios.
It's like building a puzzle, but instead of cardboard pieces, you're using like lines of code. And each line has to fit perfectly with the others to create this fully functioning system.
You're getting it. And just like with any good puzzle, the satisfaction comes from figuring out how all those pieces fit together.
I can see why people find programming so fascinating. It's like this giant puzzle waiting to be solved. And the possibilities are endless. But let's get back to our toll plaza for a second. We've talked a lot about how the system works, but what about the people who actually design and build these systems?
Yes. The unsung heroes of the toll collecting world, 3.7.pdf, touches on the importance of software engineering principles in developing these systems.
Okay, so it's not just about knowing how to code, but also about designing the system in a way that's like efficient, reliable, and easy to maintain.
Exactly. It's like the difference between building a house and designing a skyscraper. Both require skill and precision, but the scale and complexity are on totally different levels.
This deep dive has really opened my eyes to the intricacies of a system I'd honestly never think twice about. It's amazing how much thought and planning goes into something as, seemingly mundane as a toll booth.
It's a testament to the power of programming and its ability to impact our daily lives in, subtle but significant ways. But what's even more fascinating is how this technology is constantly evolving. 3.7.pdf hints at the future of toll collection, with things like congestion pricing and dynamic tolls that adjust based on real-time traffic conditions.
Okay, now that's some next level stuff. So we're not just talking about static tolls anymore. We're talking about systems that can adapt and respond to changing conditions on the fly.
Exactly. Imagine a world where your toll price fluctuates based on how heavy the traffic is at any given moment, encouraging drivers to adjust their routes, maybe their travel times. It's like having a smart assistant for your commute.
That's incredible. It's like those navigation apps that suggest alternate routes to avoid traffic jams, but on a much grander scale. It makes you wonder what other innovations are on the horizon for toll collection and, transportation systems in general.
That's the beauty of technology. It's constantly evolving, pushing the boundaries of what's possible. And who knows, maybe one day those toll booths won't even be booths anymore. We might be looking at a future of completely automated sensor-based systems that seamlessly collect tolls without us even realizing it.
Wow, now that's a future I can get behind. But before we get too caught up in flying cars and teleportation, let's bring it back to the present for a moment.
Sounds like a plan. What's on your mind?
We've covered a lot of ground today, from the basics of toll calculation to the complexities of system design and even like a glimpse into the future of transportation. But I'm curious, what's the one key takeaway you hope our listeners walk away with today?
That's a great question. For me, the biggest takeaway is that programming is so much more than just lines of code. It's a way of thinking. It's a problem-solving tool that can be applied to virtually any aspect of our lives, whether we're talking about calculating tolls, managing traffic flow, or even designing the next generation of transportation systems. It all starts with the power of programming.
That's a powerful message. It's not just about the technology itself, but the human ingenuity behind it and, the endless possibilities it unlocks.
Absolutely. And that's something worth celebrating.
Couldn't agree more. But before we wrap up this deep dive, there's one more thing I wanted to touch on, something that really struck me from 3.7.pdf, it's that idea of unintended consequences.
Hmm.
The document mentions how even well-designed systems can sometimes have, unexpected or even like undesirable outcomes.
Ah, yes, that's a crucial point, and one that often sparks debate and, further innovation. It's like that old saying, you can't make an omelet without breaking a few eggs. Sometimes progress comes with, certain trade-offs.
But when it comes to something like, toll roads,
Yeah.
what kind of unintended consequences might we see?
Well, one example is the issue of equity. While toll roads can be a great way to fund new infrastructure or reduce congestion, they can also disproportionately impact lower-income drivers. Those who may not have the same flexibility to adjust their routes or travel times.
That's a really important consideration. It's like we're trying to solve one problem, but then potentially creating another one in the process.
Exactly. And that's why it's so important to have these discussions to really consider those potential downsides alongside the benefits. It's not always about finding that perfect solution, but rather the most, equitable and sustainable one.
So it's not just about the code itself, it's about the human impact of that code.
Absolutely. And this brings us back to the importance of those software engineering principles we talked about earlier. It's not enough to just build a system that works. It needs to be designed with, ethics and social responsibility in mind.
It's like we're not just building machines, we're shaping society with those machines. And that comes with a tremendous amount of responsibility.
You hit the nail on the head. It's a responsibility shared by programmers, policymakers, and really all of us as we kind of navigate this, increasingly technology-driven world.
This deep dive has really given me a lot to think about. Who knew there could be so much depth and complexity behind something as seemingly simple as a toll booth? We've talked about algorithms, flowcharts, behavioral economics, even ethics.
It's all connected. And it really highlights how programming is so much more than just this, technical skill. It's a tool for understanding and ultimately shaping our world.
Well said. So as we wrap up this fascinating journey into the world of toll calculations, what's the one thought you'd like to leave our listeners with today?
I'd say next time you encounter any system, whether it's a toll booth, a traffic light, or even just an app on your phone, just take a moment. Take a moment to appreciate that intricate web of programming that makes it all possible. And more importantly, remember that behind every line of code is a human mind, making decisions that, shape our world.
I couldn't have said it better myself.
Hmm.
Thanks for joining me on this deep dive. It's been an eye-opening experience.
The pleasure was all mine. Until next time, keep asking questions and exploring the hidden complexities all around us.
And on that note, we'll sign off for today. Thanks for tuning in to The Deep Dive.